So today we're talking about lesson 7.8, which is factoring complex trinomials. So just a quick reminder, whenever we're factoring any sort of trinomial, the first thing we actually want to do is look for the GCF. And then secondly, we want to figure out, is it simple or complex? So if we look at our standard form, we have ax squared plus bx plus c. Okay. So simple, meaning the a, this term right here, is a 1. Complex means that a does not equal 1. Okay. So it could be a different number. It could be a prime number. It could be a composite number. But that leading coefficient, when it's in standard form, is not 1. So if we do a quick example, let's say we have 5x squared plus 15x plus 10. Oh, okay. So at first glance, this looks like a complex problem because this is not 1. However, I do have a GCF, so I always want to look and see what is my GCF. Well, I can divide every single thing by 5. So this is going to become 5 times x squared plus 3x plus 2. And then I can factor that further. So we want to look at what multiplies to this and adds to this. So 2, well, I have 1 and 2, and if I add those, then I get 3, so we're good. So I'm going to split this into x plus 1 and x plus 2. And so this was actually a simple problem once we factored out the GCF. Now we're going to do 2 problems, and we're going to do 2 different methods. So we've got factoring by grouping or by parts. Okay, so grouping means that I'm going to be grouping problems together. So we're going to do one example where we have 4x squared plus 13x plus 3. So I first want to ask myself, do I have a GCF? I don't have a GCF here, and I have this leading coefficient that is not 1. So what we're going to do is, instead of just finding 2 numbers that multiply to 3 and add to 13, we need to incorporate that 4. Now, when we're doing simple problems, incorporating the 1 is nice and easy because it doesn't change the value. But when I do 4 times 3, I get 12. And I want 2 numbers that multiply to 12 and add to 13. Well, that's going to be 12 and 1. If I add them up, I get 13. So what we're going to do here is kind of, remember how if we were to multiply these 2 out, we would end up with x squared plus 2x plus 1x plus 2, and we had our common terms in the middle. Well, we're going to split this middle term so that it has the 12 and the 1. So this is going to be 4x squared up front. This middle term is going to split, and I can rearrange it however I want. So I can have it say 12x plus 1x, or I can switch those. It doesn't matter. But now what we're going to do is we're going to group them. So I'm going to say these 2 are together, and then we're going to say that these 2 are together. And we're going to factor out the GCF. So the GCF of these first 2 is 4x. So if I divide this by 4x and divide this by 4x, then I get x plus 3. And then when I'm doing the second one, the important part is to match this sign. So I'm going to put a positive there. And then there isn't a GCF, but I'm going to put a 1 because I can technically divide each of these by 1. And then I get an x plus 3. Now when I'm doing this, I want to look and see, do I get something in the parentheses that's the same? If I did, then I did my job right. So now let's go back and say, okay, well now my GCF is actually this x plus 3. Because I can divide each of these by x plus 3. So if I divide by x plus 3, then I'm left with 4x up front and plus 1. And you can see that it's just the leading terms of the parentheses that works. All right, so let's try another example. And so let's do 3x squared minus 7x plus 2. And again, we want to ask ourselves, do we have a GCF? Well, I don't have a GCF, so I'm going to use this last example over here to remind myself. The first thing I have to do is multiply. 3 times 2 is 6. And then I want to find two factors that add to negative 7. So I know both of them will be negative. And I have negative 1 and negative 6. If I add them up, I get negative 7, so we're good. I'm going to split this, so we've got 3x squared. And again, it doesn't matter the order, so I can put the negative 1 here or the negative 6. And they both must have that linear variable with them, and then plus 2. And again, let's group these. So, okay, so we grouped 2 by 2, just like Noah went on the ark. So we've got our GCF of the first one will be a 3x. If I divide by 3x to both terms, then I'm left with x minus 2. And again, I always want to match this sign right here. Okay, so minus. And then there's no GCF other than 1. So, but if I divide each of these by negative 1, then I'm left with x. And then this becomes a negative 2. Hey, I did what I wanted. I have the exact same thing on the inside. So using that, I can then say that, well, they both have an x minus 2. And if I divide by x minus 2 and x minus 2, then that cancels. And then I'm left with 3x minus 1. So that is factoring by grouping. Okay. Now, there's another way that's just a little bit less. And I actually had another teacher teach this method to me, and I'm not really entirely sure what it's called, but we're going to go ahead and try it. So 2x squared minus 5x minus 7. Okay, so do I have a GCF? No, I don't. The first step is still going to be the same. I still have to do 2 times negative 7 to get negative 14. And I still want two numbers that add up to negative 5. Okay. So that's going to be negative 7 and 2. If I add them, I get negative 5. All right, so just like in the simple method, I can say, okay, x times x is x squared. I'm going to ignore this 2 for just a little bit. And I'm going to take my negative 7 and my positive 2, and I'm going to put them in there. Now I'm going to come back and say, okay, I can't ignore my positive or my leading coefficient. So if you divide each of these by that, one of them simplifies, and one of them doesn't. So this one becomes x plus 1 because 2 divided by 2 is 1. Now, if we want to get rid of this fraction, I can multiply both terms, both the x and the 7, so both this and this, by the denominator. So if I multiply this by 2, I get 2x, and if I multiply this by 2, then the 2's cancel, and I'm left with negative 7. So this is just a much shorter way of doing it. So let's try that one more time. Okay. So we've got negative 40n squared plus 70n minus 15. Okay. And again, if this method doesn't make sense, you can do the factoring by grouping or by parts. Every time, all the time. Do we have a GCF? We do. It's negative 5. So let's divide. So we get 8n squared minus 14n plus 3, okay? So since I have a GCF out front, I actually don't need to incorporate that when I'm multiplying. I'm just going to multiply what's my A and my C, this and this. So that gives me 24. I'm looking for two numbers that add up to negative 14. So I know they're both negative. Well, 12 and 2, they would add up to negative 14. So then I say, okay, negative 5, and then I have n minus 12 and n minus 2. And then I can't forget that leading coefficient. Okay, so divide each by 8. Okay, let's simplify them. So we get n minus, this is now simplifies by 4. So this is 3 halves. And this one would be simplified by 2 to give us 1/4. Okay, so if I multiply everything in each term by the denominator, so I'm going to multiply this one by 2 and this one by 4, then I'm left with negative 5. Okay, n times 2 is 2n. 3/2 times 2, well, that cancels, and I'm left with the 3. N times 4 is 4n. And 1/4 times 4, those cancel, and I'm left with -1. And that is our final answer. That's it for today. Let me know if you have any questions, and we'll go over the homework tomorrow.